Yes. Good morning to all of you. In the previous theory session, what about the topic we have discussed? Can you people type it in the chat? In a topic we discussed in the previous session, theory session. I'm speaking about the theory session. Can you type it in the chat? Yes, ports. Yes, working of port 1 pathom. Fine. Then we have discussed about the working of port 1. So we have discussed only the write operation, writing logic 0 and writing logic 1 we have discussed. Okay. We will go with that. We will continue with port 0 now. Fine. So today we are going to discuss about the ports of Intel 82 microcontroller. Okay. Then if time permits, we will be getting into the introduction of timer bar counter of Intel 82 microcontroller. Fine. Okay. So now we will get into the operation of port 0. Fine. So this is the initial condition. I'm again asking you some questions, especially in classroom 2, there is no response. Okay, so the questions for only classroom 2 now. Fine. Can you people say to write logic 0, which instruction we have to use? To write a logic 0 to a port pin, which instruction we have to use? Kindly type it in the chat. Classroom only answer type on. Which instruction we must use to write logic 0 to the port pin? Yes? In the instruction use pannapa. Kindly respond. It's the very first session. Yes, very good. Classroom 1 la nariya respond panna. Classroom 2 la oru response varadhu. Yes? Can I point and ask? 19T115 Sakti Abhirami. See, 72 பேர் இருக்கும் கரெக்ட்டா? இந்த கிளாஸ் ரூம்ல faculty எல்லாரும் சேர்த்து 72 students, approximately 65 students இருக்கும் கரெக்ட்டா? Move P0,00H. Very good, Karthikeyan. It is a byte operation, correct? It is a byte operation. If you are writing this particular data, you miss the hash. Yes, actually it is move P0,00H. See, it is a byte operation. What you have mentioned is a byte operation. I am speaking about the bit operation because here we are studying the operation of individual pin. Yes, port 0 level ஒரே ஒரு பின்னோட கன்ஸ்ட்ரக்ஷன் தான் நம்ம இங்க பார்க்கறது. Fine. Similarly, the other 7 pin construction will be same like this. Okay. So what you have typed is a byte operation. Fine. I am asking about a single bit. Can I type it in the chat? Yes. Classroom 1 la nariya per answer type pannirukeenga. Very good. The answer is correct. So CLR P0.0. That is the instruction to write logic 0 to any port. Fine. So here we are speaking about the port 0. So I am considering P0.0. That means here all the other port pins of port 0, it is going to function same. Fine. So I am generally mentioning here as P0.x. So the value of x may be from 0 to 7. If you consider any pin, it is going to function in this way only. Fine. So when we are writing the instruction CLR P0.0, automatically through the internal bus, this particular latch is going to be written with 0, correct? So internal bus we are going to have 0 here. Fine. Before that, we have to know one thing. We are having a control line. Yes. If the control line is 0, then only the input-output operation can happen. Otherwise, it is going to function as a what? Port 0 alternate function in What about the alternate function of port 0? Yes. Port 0 alternate function in Yes, it is going to also function as an address data bus. Correct? Especially port 0 is going to have a multiplex lower order address line and the data line. Correct? Very good, Daniel. Very good. Very good, Dixon. Very good, Lotus. Yes. So we will be having a multiplexer here. This multiplexer, it is going to have 2 inputs and 1 output. This selection can be done with the help of this control line. If the control line is 0, then the connection is with the complemented output of P0.x latch. Fine. If the control signal is 1, it is going to be connected with the address data line. That means the complemented value of the address or data line. Fine. I hope it is clear to everyone. So now we are speaking about the write operation. That means we are speaking about the port operation. Fine. So during the port operation, it is going to have logic 0 automatically. Whenever your microcontroller is trying to do some external memory access operation, at that time automatically the control becomes logic 1. Fine. So now we are considering it is going to function as a IO port. Fine. So control is 0. So we no need to bother about the data line. As control is 0, this mux is going to connect with, the output is going to connect with the input at 0. Yes. So this line will get connected now. Okay. So no need to worry about the address data line now. Fine. So it is considered as don't care. Fine. Okay. What about the output of the AND gate now? What about the output of this AND gate now? If any one of the input to AND gate is 0, then output is also 0. Fine. What about the condition of the upper FET? Mala field effect transistor condition enable. As the gate is given with 0, what about the condition of the upper FET? On state or off state? Yes, very good. It is in off state. Fine. So this path will get open. Fine. Coming to this, see, when I am saying it is a IO operation, this is going to happen automatically. If the pin is going to function as an address data line, the control becomes 1. At that time, no need to worry about the latch condition. Whatever you are writing in the port latch, it is not going to be considered. When, if it is going to function as an address data line, that means we are having 2 pathways. One is from the port latch, the other is from the address bit internally. Fine. So now, as we are discussing about the logic 0, internal bus logic 0 on the now the latch should be enabled. So write to latch signal will get 1. So at that time, the content available in the internal bus bit is getting into the latch. So after that, the latch will be disabled. So now no need to worry about the internal bus logic. That's it. Fine. What about the output at Q bar? If the latch is filled with logic 0, what about the output at Q bar? It is going to be 1. Yes? Fine. So what about the condition of the lower FET now? Key-level field effect transistor conditioning. Yes? Whether it is going to be on or off? Yes, very good. It is going to be on. Fine. If I say it is on, almost it is going to act as a closed path. So this pin is currently going to connected with ground. Is it clear to everyone? So what about the logic available at the pin? What about the logic available at the pin now? Transistor on anachi. So this pin, it is getting connected to the ground now. So logic 0 is going to be available. Yes. So what logic we have written? 0 logic. So what logic available in the pin? 0 logic. Fine. So whatever you are writing in the port latch bit, that is going to be reflected in the port pin. Fine. Okay, fine. Now coming to writing logic 1. Here also the same thing. Control is 0. Don't care about the address data line. So the AND gate output is 0. Again, the upper FET is off. So it is going to be an open set. Fine. Coming to the write operation. Internal bus, we are placing the logic 1. For this particular thing, which instruction we have to use? If I want to write a logic 1 on a port bit, which instruction we have to use? Yes, set B. Yes, set B, P0.x. X may be 0 to 7. Any value you can do. Fine. Now, which of the signal will get enabled? Read latch, write to latch, read pin. Which signal will get enabled? Set B abdina we are going to write logic 1. So enable agum. Which of the three signal must get enabled? Read latch or write to latch or read pin? Yes, write to latch is going to get enabled. Once it got enabled, what is getting into the port latch? Port latch la enna logic poi store agum? As the input at D is 1, it is getting stored. Fine. Once it's stored, the write latch signal get disabled, will get automatically disabled. Fine. When you are writing the instruction set B, the corresponding pin valiya one logic varum, write to latch enable agum, it will get stored into the latch. That's all. Store aanadukku appuram namakku no need to worry about the internal bus connect. Fine. Now what about the output at Q bar? Now what about the output at Q bar? Yes, 0. Very good. So what about the condition of the lower FET? Yes, very good. Off. That means it is also going to work as a open circuit. What about the condition of the pin now? What about the condition of the pin now? The pin oda condition ipo eppadi irukku? Is it 1? See, both paths are getting open circuit. Correct? Ideally, I am speaking. Neither 0 nor 1. Very good. That means the pin is floating. That means high impedance stapler. Fine. Okay. What logic we have written in the latch? 1. What we must get at the pin? What logic we must get at the pin? Enna logic namakku venum? 1 eluduna 1 varanum. Correct? Yes. So for that we are now going to add an external circuit, that what we call it as, in the previous class itself I have told you. We have to put an external circuit so that we can keep the pin at logic 1. If the pin is floating, we can make either, yes, very good. So port 0 requires external pull-up circuit. Very good. Fine. So pull-up circuit means what? We are connecting the pin to 5 volt through a resistor. Typically, the value of the resistor is 10 kilo ohm. Fine. Yes. Okay. Now the logic at the pin is 1. Fine. Please remember, when we are using port 0, we have to build an external pull-up circuit so that the port 0 is going to work. Fine. Logic 0 எழுதுனப்ப பிரச்சனை இல்ல, but logic 1 எழுதுனப்ப கண்டிப்பா நமக்கு என்ன வேணும்? External pull-up circuit வேணும். That means when you are doing input-output operation, okay, input-output operation through port 0 pins, you must connect pull-up circuit externally. Then only the port 0 is going to function for I/O operation. Fine. That's it. Now we will go with the read operation. Fine. What must be the condition we have to do so that a port pin can be configured as input? Kindly type it in the chat. Enna logic na eludunum port pin la enna, I mean port register bit la enna logic na eluduna ennude port pin input ah configure agum. Yes, very good, very good. We have to write logic 1 at the port latch bit. The same thing. Eludiyaachu. Yes. Now it is going to function as an input port. Fine. Eppadi paakalaangala? For example, if you connect an input device with logic 1, fine. Already your port pin is at logic 1, 5 volt only. You are also applying a 5 volt. Yes. If I want to read this particular port pin, which instruction we have to use? The port pin na read pannona enna instruction use pannom? Any idea? Port is a single bit, correct? So it has to be copied to carry bit only. Fine. So logic at port pin to carry. Any instruction use pannom? Yes. Destination is carry flag bit. Source is port pin. Yes. Move C, P 0.x. Very good. Fine. Generally we are speaking, so we can have 0.x. Very good. Okay. Now, which signal will get enabled out of the read latch, write to latch, and read pin? Which signal will get enabled? இந்த இன்ஸ்ட்ரக்ஷன் எக்ஸிக்யூட் ஆகிறப்ப எந்த பின் எனேபிள் ஆகும், எந்த buffer enable ஆகும். Yes, very good. The read pin buffer will get enabled. Once it get enabled, this logic at the port pin is available at the internal bus. Fine. So it won't get into the latch. Why? Because write to latch is disabled. Similarly, it is not going to get anywhere. All other paths are blocked. Only this path is allowed. Fine. So what logic we will have at the internal bus now? Internal bus ku enna logic pogum po? It is connected with the pin. So one logic we are getting. Fine. Suppose when you are reading, if your input device is providing logic 0, what is going to happen? What is happen? What happened? Input device la logic 0 kuduchuna namakku enna data ulla varudhu parunga automatically 0 only, irrespective of this pull up circuit. See, a pull up circuit can be pulled low by connecting the pin to ground. That is the logic. Fine. So who is dominating here? Even though we have written 1 at the latch and the pin logic is 1 before, when we are connecting a input device with low logic level, it pull down the port pin to logic 0. That's the condition. Fine. So here the condition of the pin depends upon the input device. That's all. So whatever the condition of the input device, it is getting into the internal bus. That's it. Is it clear to everyone? Is it clear up to this? Shall I proceed? Yes. Okay. Fine. Yes. Okay. So now we are going to see the alternate function. So here we are assuming whether it is going to be address or data. No need to bother about it. So we are having something from here. Now it is going to function as an address and data bus. So automatically the mux input must be connected with 1. So what must be the logic getting at control pin? Control pin enna logic la irundha enakku idu address data bus function agum sollu. 0 means IO port. Fine. Yes, very good. In the pin na 1 set pannana illa 0 set pannana, whether I am doing or CPU is doing automatically, whether the microcontroller is doing this thing or I am doing. Yes, very good. When microcontroller do this, whenever it need address and data bus, that means whenever it want to access external memory at that point of time, automatically the control signal become 1. Fine. Now we are considering here we are having an address or data, whatever it may be. Fine. So it is going to be 0. I'm a 0 assume. What about the output of AND gate now? What about the output of AND gate now? Yes, very good, 0. So what about the condition of the field effect transistor? Upper FET condition enna irukum? Yes, off. So it is going to be open circuit. What about the output at the NOT gate? Yes, very good, 1. So now the mux is connected with the output of NOT gate, not with the port latch. As the control pin is 1, automatically this connection is going to establish. So inga switch keela connect aayirukku mari irukku, actually mela connect aayirukku. Fine. So now we are getting the logic 1 to the field effect transistor, lower FET. Fine. What about the condition of the FET now? What about the condition of the field effect transistor now? On state. Very good. So automatically what is going to happen? It is going to work as a closed path ideally. Fine. So this pin is connected to ground. So what about the logic at port pin? Yes. What about the logic? 0. Okay. So address or data, whatever it may be, I mean, whenever it send the address bit as 0 or 1. So 0 ku nama paathirukom, 0 eludirna enakku enna varudhu port pin 0 vandu. That's it. See, this is the working. Fine. Similarly 1 appadina enna agum, both address and control. Fine. See, control it must be 1 only. So now we are considering address data bit 1 varudhu nu eduthukom. Now the upper FET is turned on. Fine. So the output of the NOT gate is 0. So the lower FET will get turned off. So it will be like this. So what about the logic at the pin now? What about the logic at the pin now? Yes. Yes, very good. One logic. See, inga address or data line la enna value varudho adha inga. See, this is the multiplexed thing, correct? Eppa address varum data varumradhu yaar identify pannuva? Which signal will distinguish? Which signal can be used to demultiplex the multiplexed address and data? Yes, very good. ALE. Fine. Okay, appa ore oru kelvi dhaan kekalama. If I am interfacing external memory with my microcontroller and it is going to access the external memory, what about the port 0? Port 0, whether we can connect input output device? Is it possible? Is it possible or no? No, definitely no. Yes, when you are going for external memory, you have to sacrifice port 0 for what purpose? Multiplex the lower order address and data line the function of the port. Fine. That means irrespective of the port latch, it is going to function. That's all. Fine. When you execute the instruction move X, automatically this particular pin, it is going to function as a address data line, external data transfer or external program memory access, whatever it may be. Fine, it is going to function as an address data. Is it clear to everyone? Any doubts? Okay, fine, very good. Okay, now we are getting into the operation of port 2. Whether port 2 is also having alternate function? Whether port 2 is having any alternate function? Yes, what about the alternate function? What about the alternate function? When we are saying external memory access, we need address and data bus. Fine. So externally we can address up to no Antony Surya, it is not higher data bus. Here data is only 8-bit, address it is going to be 16-bit. Fine. Not multiplex the higher order address line Danya, it is simply higher order address line. Yes. Okay. Anyhow, I appreciate for you people's answering for my question. Okay, classroom 2 la வந்து எல்லாரும் தூங்குறோம்னு நினைக்கிறேன். 81 பேர் including faculty காமிக்குது. Students வந்து around எத்தனை பேர் இருக்கணும் அப்படினு பார்த்தோம்னா 1 2 3 4 5 76 students we are having classroom 2 ல. பட் யாருமே ரெஸ்பாண்ட் பண்றது கிடையாது. ஸோ எப்போவாவது ஒரு தடவை கார்த்திகேயன் பண்றாரு, இல்லை விக்னேஷ், தீக்ஷா ரிப்பீட்டடா இவங்க தான் பண்ணுவோம். 3-4 பேருக்காக கிளாஸ் ரூம் 2 ல கிளாஸ் எடுக்கிறோம். ஃபைன். கிளாஸ் ரூம் 1 ல ஒரு 7-8 பேர் நம்ம ரிப்பீட்டடா ஆன்சர் பண்றோம். தட்ஸ் ஆல். ஃபைன். இட்ஸ் நாட் அ ஹெல்தி திங். ஃபைன். சி போர்ட் 0 இப்படிதான் இருக்கும், இதான் ஆப்ரேஷன் சொல்லிட்டு போயிட முடியும். ஃபார் வாட் பர்பஸ் வி பீப்புள்ஸ் ஆர் ஒர்க்கிங்? சி நாளைக்கு வந்து நம்ம இது எதுவுமே புரியல, அண்டர்ஸ்டாண்ட் பண்ணிக்க முடியல அப்படின்னா எம்பெடட் சிஸ்டம் மறந்துடலாம். சரியா? Without knowing the microprocessor and microcontroller concept, you cannot understand what things are speaking in embedded system. Okay. See, you can have a good career path. Fine. So, in the microprocessor, nalla learn panna appadina automatically embedded system போலாம். So, easy நீ understand பண்ணிக்க முடியும். இதை விட advanced microcontroller ஓனா படிக்க முடியும் உங்களால. Fine. When it can be done, if you understand this simple microcontroller functioning, yes, you can understand the higher levels. Without knowing this thing, you cannot understand the port operation of any microcontroller. I will challenge you. Okay, fine. So now we will go with the operation of port 2. Fine. So this is the circuit for port 2. First, we will go with the write operation. Obviously, we are going to write logic 0 now. So the internal bus. Before that, what we have to tell? If it is going to function as a IO port, what about the control logic? Logic at the control pin? Yes, 0. Very good. Fine. So we no need to bother about the address here also. So So output of AND gate is 0. So the internal puller is going to work. We are having a different thing here. So அங்க நம்ம போட்டிருந்தது ஒரு field effect transistors, correct? So 0 input கொடுத்தா off ஆகும், 1 input கொடுத்தா on ஆகும். That's it. Fine. Here we have a internal FET pull-up circuit. Fine. See, இதுக்குள்ள வந்து ஒரு circuit இருக்கு, pull-up circuit இருக்கு. It's somehow different. இங்க logic 0 போனா it is going to work as a weak internal pull-up. It is going to work as a weak internal pull-up. Please remember this. Okay. Fine. That means this pin is pulled high only, always. Whether it is weak pull-up or strong pull-up is going to be decided by the output of AND gate. That's all. Okay. Now coming to this, we are writing logic 0 here. Write to latch signal enable. Latch la poi store aiduchi. So at Q we will be having logic 0 only. So it is given to the NOT gate. Yes, the output of NOT gate, it is going to be 1. What about the condition of the lower FET now? Yes, on. So it is going to be behave as a closed path. So it is going to be connected as 0. Even though we have a weak internal puller, as this transistor getting on, it is directly connected to ground ideally. That means logic 0 will be available. Similarly, we will go with logic 1. Yes, shall I proceed? Yes, fine. Okay, writing logic 1, same thing, control pin 0. So we no need to bother about the address and data line. Here I am writing it as only address line, not address data line. Fine, because it is going to carry only the upper 8 bit of the address. Port 2, it is going to carry the upper 8 bit of the address. Fine. Now, so it is going to work as a weak internal pull-up. So we are writing logic 1. So write to latch signal get enabled. So it gets stored into it. The output of NOT gate becomes 0. So what about the condition of the transistor now? Yes, off state. So it is going to open circuit. Fine. So we are having a weak pull-up. Yes, that's all. Okay. In some application, if you are writing, if you are working with port 2, fine, it is going to deliver only a small current. Voltage logic வந்து எனக்கு என்ன இருக்கும், one logic இருக்கும், but it cannot able to drive the device. Generally, what we people have to do is we have to provide external power supply for your devices. Whatever you are interfacing, you have to provide external power supply. That means the power you are giving to your microcontroller should be 5 volt. Fine. Say for example, I am going to control a motor operating at 12 volt. That means we have to provide an external power supply. So that must be controlled with the help of port pin. Fine. So this things and all you can learn only when you are doing project. Okay. Fine. Now read operation. We will go with the read operation. Yes. So 0. Yes. So no need to worry about the address line. So again we will be going to have a weak internal pull-up. Fine. Writing logic 1. Why we are writing logic 1? To configure a port pin as input, it must be written with logic 1. So we are doing all those things. Yes. Okay. Now we are going to connect the input device. So which is also providing the logic 1. Fine. When we are reading this particular pin, which signal will get automatically enabled? Out of the 3 signal, read latch, write to latch, read pin, which signal will get enabled? Yes, read pin. So the logic at the pin is getting into the internal bus. So that's why I have told many times, write to latch, read from pin. நீங்க எழுதுறது latchல போய் write ஆகும், ஆனா read பண்றது pinல இருந்தா read ஆகும். இந்த port latch read ஆகாது. Whenever you are doing read operation, this buffer will get enabled. Fine. So read pin signal goes high. So the buffer is getting enabled. So that input is getting into the internal bus. So we are having logic 1. Fine. Suppose if the input device is providing logic 0, what is going to happen? Suppose if the input device is going to give logic 0, what is going to happen? Yes, logic 0 will get into the internal bus. That's it. Fine. So that's all about the read operation. Fine. Quickly we will move to the alternate function. So now we are going to speaking about the speak about the alternate function of port 2. Fine. So now it is going to function as a higher order address line. Upper 8-bit of the address is going to be carried out by port 2 now. Fine. What about the condition of the control now? Control signal, yes, 1. Fine. If we are writing 0, address bit 0, so the connection will be like this. It is connected to this point. The output is connected to Maxoda input 1 la connect. Irrespective of 0, it is going to connect with 1. Fine. That means in 0 logic in 0 da. What about the condition of the internal pull-up? Whether it is going to be act as a weak or a high, weak or strong pull-up? It's going to work as a weak pull-up because the AND gate output is 0. Fine. So coming to this, so 0 logic is available at the address line. So 0 is getting as input to NOT gate. So the output of NOT gate become 1. Fine. So that's all. So the transistor is going to on. So it is going to be logic 0. Fine. Similarly, when we are writing the address bit at 1, what will happen? We will check. So now also control pin is 1 as it is address bus. Now address bit is going to be 1. So internal pull-up is going to be what is a strong internal pull-up. See, there is a circuit here. Fine. Normally it is going to work as a weak internal pull-up. Fine. When the AND gate input is 0, if AND gate input, AND gate output is 0. If the AND gate output is 1, it is going to function as a strong internal pull. Fine. Now coming to this, so the address bit is 1. So input to the NOT gate is 1. So output to the NOT gate is 0. Fine. What about the status of the transistor now? Yes. Off. Very good. So it is going to be an open path. So the port pin P2.x, it is going to be at logic 1. Fine. See why we are having strong internal pull-up activated when we are writing the address logic as 1. Okay, we people know we don't have any latch for the upper 8-bit of the address. Correct? Generally, 85 microprocessor, they will use to have a driver. Fine. But here, by default, when we are writing the address logic as 1, the pin must be strongly pulled up so that the logic 1 is going to be a part of the address. Yes, the part of the address logic 1 and it is strong maintained, the memory location will get selected properly. For that purpose, we are having a strong internal pull-up circuit here, activated. Fine. See, the address bit 1 strong pull-up get activated. Fine. So that's the reason. Okay, that's all about the operation of port 2. Now we will get into the operation of port 3. Yes, operation of port 3. What about the alternate function of port 3? Can you people type it in the chat? Whether it is going to function as address bus or data bus. What about the functionality of port 3 pins? Any idea? Regarding port 0 and port 2, the entire port it is going to function as an address and data line. Whereas port 2 carries higher order address, port 0 carries multiplex lower order address and data. What about the operation of port 3? Alternate operation of port 3. Yes, each pin of port 3 is having individual alternate function. Yes, very good, very good. Fine. Now, this is the construction of port 3 pin. Fine. You people have to understand one thing. When I am saying alternate function, that means that particular pin can be either functioning as a port pin or as for the alternate operation. Yes, both cannot be done same at the same time. Yes. Okay. Now we will consider the writing logic 0 here. Okay. Generally, this alternate output function is going to remain high only. Fine. During the port operation, automatically in the alternate output function 1 da irukkum. When we are doing the alternate output function, Can you people say what are all the alternate output function we are having? Yes. What are all the alternate output function we are having? I mean, என்னென்ன ஃபங்க்ஷன்லாம் output function இருக்கு alternate function port 3 ல. I will type the signal you people identify. Wait a minute. I'm typing. Once I have typed, I will post. Yes, I have typed all the alternate function of port 3 pins. Okay. Chat la type பண்ணிருக்கேன், refer பண்ணிருக்கேன். Yes. So TXD, RXD, IND 0 bar, IND 1 bar, T0, T1, RD bar, WR bar. Yes. Okay, இதெல்லாம் output function சொல்ல முடியுமா? Which are the signals are from the microcontroller to the outside world? Out of the 8 signal, which of the signals are output signals? Just think and tell. TXD na meaning enna? Yes, very good. TXD, it is output pin. It's an output operation. We are transmitting serial data. Fine. So that is one output function. What about the other thing? What about the other thing? Yes, very good. Write bar. This signal is going to be generated by the microcontroller only. See, memory நம்ம select பண்ணதுக்கு அப்புறம் read பண்ணுமா write பண்ணுமான்ற signal யார் generate பண்ணுவா? Microcontroller only. So write bar signal. What about RD bar? RD bar அப்படின்னு ஒண்ணே read பண்ண போறோம்னு நினைச்சிட்டீங்களா? Whether the device is going to generate the RD bar or microcontroller is going to generate the RD bar. See, read or write operation. Who is going to decide that operation? Input output device or a microcontroller? Yes, microcontroller only. That means microcontroller is going to generate the RD bar and WR bar signal. Yes. See, out of the 5 signals, 3 signals are output function. The remaining 5 signals are input function. Okay. Now we are speaking about the IO operation. Later we will discuss about the alternate function. As of now, when a port pin is going to function as a normal IO port, fine. This alternate output function pin, it is by default 1. Okay. Now you consider we are going to write logic 0 at the internal bus. So write to last signal enable. Yes, it gets stored. Okay. So what about the output of the NAND gate? The NAND gate would output enna varum? What about the output of NAND gate? The inputs are 1 and 0, correct? Inputs are 1 and 0. Yes, very good. The output of NAND gate is going to be 1. So what about the condition of the transistor? On. Yes. So this path is going to be what is a closed path. So we'll be having logic 0. Latchless 0 logic, pinless 0 logic on that. Fine. Next, writing logic 1 path. The same here. Fine. 1 logic is getting into the latch. Fine. So 1 1. What about the output of NAND gate now? Yes, 0. Very good. 0 means what about the condition of the field effect transistor? Off. That means it is going to work as an open path. So P3.x. What about the logic at P3.x? 1. Okay. See, generally ஒரு விஷயம் நல்லா புரிஞ்சுக்கணும்பா. நல்லா புரிஞ்சுக்கணும். When I am saying about the input operation, next slide la paakalam, we have to consider a most important thing. Fine. Okay. So now we have written logic 1. It is available at the pin also. Now we are going to discuss about the read operation. Fine. What about the condition of the alternate output function? In this case also. In this case also, it is going to be 1. Fine. Okay, we all know to configure a port pin as input, one must be written on the latch. So we are writing it. So it is functioning like this. Okay, this is a very important thing I want to tell you. Fine. In the case of port 0, when we configure a port pin as input, the pin is getting into the high impedance state or floating state. That means it is neither connected to 0 nor connected to 1. Yes? Fine. If a port pin is like that, that we call it as a true bidirectional port pin. True bidirectional port pin. எப்போ நான் ஒரு போர்ட் பின்னை இன்புட்டா கான்ஃபிகர் பண்றனோ ஆட்டோமேட்டிக்கா அது ஃப்ளோட்டிங் ஸ்டேட்ல தான் இருக்கணும். Because the logic is going to be given by the input device only. Fine. You consider this case. In the case எடுத்துக்கோங்க. இப்போ இது இன்புட்டா கான்ஃபிகர் ஆயிருக்கு. Fine. இது ஆனா floating இல்ல. Due to the internal puller, it is pulled high. Correct? That means even if you didn't connect any input device with this port pin, if you read, you will be getting as logic as 1 only. Fine. Irrespective of the input given by the input device. Input device நான் connect பண்ணலாம்னா எனக்கு என்ன லாஜிக் கிடைக்க போகுது? read பண்ணா 1 தான் கிடைக்கும். Fine. But there in the case of port 0, if you are going to work with port 0 for input operation, you no need to have a puller. That means what? Whatever the logic given by the device, but device எப்படி கொடுக்கணும் logic? Device must provide the logic 1 as well as logic 0. Whereas in this case, device வந்து நார்மலா எனக்கு எந்த டேட்டாவும் கொடுக்கலனாலும் will be having logic. But if the device pull the pin low, at that point in both ports you will be having 0 only. Fine. Okay, now coming to the read operation. I am connecting an input device. Okay, it is providing logic 1. So already the port pin is in logic 1 only. Fine. Now the read pin will get enabled. Fine. There is no enable signal for this buffer. That means what? When this read pin get enabled, whatever the logic at port pin, it is getting into the internal bus. I hope it is clear to everyone. That means when we are doing IO operation, the alternate input function is also getting the logic available at the pin. The pin la enna logic irukundrathu the alternate input function ku pogum, but it won't be accepted. Whenever we are doing the input function, at that time only it will accept. Okay, fine. So now you people can understand. So read operation பொறுத்த வரைக்கும் whatever the logic given by the input device is getting into the internal bus in this manner. Fine. Now we will get into the alternate function of port 3. Fine. As I told earlier, TXD, RD bar, WR. These are the 3 alternate output function we are having in port 3. Yes? Fine. One more important point, kindly note to put material there. To enable the alternate output function, like what we done for configuring a port as input pin, we have to write logic 1 only. For example, எனக்கு TXD transmit பண்ணும் data அப்படின்னா port latchல என்ன value எழுதிருக்கு, corresponding bitல we have to write logic 1 only. So then only the alternate output function will get activated. Fine. Okay, let's discuss. So one logic நம்ம எழுதியாச்சு. Yes. So now we are having one of the input to the NAND gate is 1. The other input is decided by the alternate output function. Say for example, if your microcontroller is transmitting logic 0, in the pin logic 0 வருதுன்னு வெச்சுக்கலாம். So what about the output of NAND gate? It is going to be 1, so the FET is going to be on, so the pin is going to be pulled low. That's it, 0. Fine. Suppose inge 1 எழுதினா என்ன ஆகும்பா சொல்ல முடியுமா? If the alternate output function is logic 1, இங்க என்ன வந்திருக்கும்? AND gate output என்ன வந்திருக்கும்? NAND gate output 1. See, if the alternate output function is 1, that means if your microcontroller is transmitting the bit 1 அப்படின்னு சொன்னோம்னா இங்க 0 வந்திருக்கும், transistor off ஆயிருக்கும். Due to the pull-up circuit, we will be having 1 logic at the pin. I hope it is clear. Latchல நான் 1 எழுதிட்டேன்னா whatever the alternate output operation you are doing, that is going to reflect at the port. That's all. Okay, now we are going to discuss about the alternate input function. So இதுக்கு alternate input function the same thing what we are going to do is latchல 1 எழுது. That means we enable the alternate function. In the case of port 3, we must write logic 1 at the port. Fine. Now alternate output function நமக்கு 1 இருக்குது. Fine. Why it is 1? See, ஒரு பின்னுக்கு either alternate input function இருக்கலாம் இல்ல alternate output function இருக்கலாம். ரெண்டுமே இருக்கு இங்க. Fine. So இதுக்கு முன்னாடி நம்ம பார்த்தது எல்லாத்துலயுமே alternate output function மட்டும் தான் கான்சென்ட்ரேட் பண்ணோம். Fine. So இங்க நம்ம alternate input function பத்தி பேச போறோம். So at that point of time also the alternate output function is going to be 1. பிசிக்கலா நமக்கு வந்து இங்க பாத்தீங்கன்னா எந்த ஒரு alternate output function இருக்காது input function இருந்தா. That means what I am saying, ஒரு பின்னுக்கு alternate input function இருக்குன்னு சொன்னா கண்டிப்பா alternate output function இருக்காது. Fine. But in common we are studying the port 3. That means what? Alternate output function நடக்கிறப்ப மட்டும்தான் இதை கன்சிடர் பண்ண போறோம். Otherwise this pin is going to be logic 1 only. So the output of the NAND gate is going to be 0. So it is going to be open circuit. So due to the internal puller, it is going to be having logic 1. Fine. Now by default logic 1 தான் இங்க நமக்கு இருக்க போகுது. Fine. If the input device, for example INT 0 bar, this one is actually bar I have missed. These two signals are active low. Fine. T0, T1, they are negative edge trigger. Then RXT, it is a level signal. That means இங்க logic 1 நம்ம கொடுத்தோம் அப்படின்னா இங்க நம்ம என்ன பண்ணல பாருங்க, ரீட் பண்ணணும்னு அவசியம் கிடையாது. Alternate input function cannot be read by the CPU. Automatically this pin logic is getting into the alternate input function, but it won't get into the internal bus. இந்த internal bus க்கு வராது, டைரக்டா என்ன ஆகுது, இந்த input function கே போயிடும். That's it. For example, if you consider INT 0 bar or INT 1 bar, if this pin is getting from logic 1 to 0, எனக்கு ஒரு edge create ஆகும். So that is sensed by the interrupt circuit. Fine. So இந்த pin எங்க போய் கனெக்ட் ஆயிருக்கும், INT 0 bar இருந்தா interrupt pinல கனெக்ட் ஆயிருக்கும். Similarly INT 1 bar இருந்தா interrupt control unit ஓட கனெக்ட் ஆயிருக்கும். If it is counter input, timer ஓட கனெக்ட் ஆயிருக்கும். If it is RXD pin, it is connected with serial UART. Fine. See, based upon the alternate input function, each pin. See, in general, we are speaking about the port 3 operation. Fine. But when we are saying an individual pin, say for example RXD, meaning என்ன, receiving serial input data. அப்ப இங்க வர data எங்க போகாது, port pin வழியா, I mean the port pin வழியா internal bus க்கு போகாது. It will get directly enter into the serial UART. So ஒரு bit உள்ள போய் store ஆயிடும். That's it. Fine. I hope it is clear. Now if the device is writing logic 0, alternate input function is getting into that corresponding control thing. If it is a timer bar counter T0, T1, if it is a interrupt control unit INT 0 bar, INT 1 bar, if it is a serial UART RXD, see individual block க்கு இந்த ஒவ்வொரு பின்னும் கனெக்ட் ஆயிருக்கும். Fine. So you have to imagine, but here port 3 in general we are speaking. That's why alternate output function, input function ரெண்டுமே காமிச்சோம். Fine. So with this all ports of 8051 are over. I hope it is clear to everyone. Port 3 மட்டும் கொஞ்சம் அண்டர்ஸ்டாண்ட் பண்ணிக்கிறதுக்கு கஷ்டமா இருக்கலாம். If you are keep on working on the hardware, you people understand. Okay, that's it. So we can revise. How many ports are available in 8051 and what is the size of each port? Can you people type it in the chat? How many ports we are having in 8051 and what about the size of each port? Yes, 4 ports we are having. Each is going to have 8 pins. That's it. Which port of 8051 can be used as address and data bus during external memory access? Port 0 and 2, very good. Which port of 8051 doesn't have an internal pull-up circuit? In the port internal pull-up circuit kadayadu. Yes, very good. Port 0. Which port of 8051 doesn't have any alternate function? Yes, port 1. Very good. Name the SFRs associated with the ports of 8051. என்னென்ன ரெஜிஸ்டர்லாம் இருக்கு போர்ட்ஸ் ப்ரோக்ராம் பண்றது? Yes, to program the ports, each port is having a register, correct? What about the name of the ports? Port registers. Port oda name port 0, port 1, port 2, port 3 and so on. What about the name of the register to program the ports? Yes, P0, P1, P2, P3. Very good. R0 to R7 kadayadu Kumar. P0, P1, P2 and P3. 4 port register we are having, each corresponding to the ports. Fine. Write the instruction to configure port pin P3.3 as input pin. Yes, very good. Set P3.3. Write the instruction to set port pin P2.0 of Intel 8051. Yes, very good. Set P2.3. Write the instruction to reset the port pin P2.5. Yes, very good. CLR P2.5. Very good. Write the instruction to toggle the port pin P1.7. P1.7 la enna logic irukko adha complement pannom. That we call it as toggle. Which instruction we have to use? CPL Danya. Okay, kindly change it. CPL. Okay, CPL P1.7. Write the instruction to configure port 3 of Intel 8051 as input. Entire port input configure பண்ணனும்னா என்ன பண்ணணும்? Yes. Any idea? Set BP3, whether it is valid thing, kindly check it and in Surya. Set B means setup bit. We are speaking about an entire port. Yes, yes. We are speaking an entire port. So we have to write FF. Okay. 1 and எழுதுனா என்ன ஆகும்? P3.0 மட்டும் தான் input configure ஆகும். Yes, that is the correct answer. Okay, thank you. So now we are going to get into the timer bar counter. So it is a new concept to all of you people. Correct? Okay. Can you people say all of you are having digital watch or analog clock in your home? Correct? Yes. Is it possible to connect LED in P1.0 and switch in P1.1? Is it possible? P1.0 LED யும் P1.1 ல switch connect பண்ண முடியுமா? அதாவது ஒரே போர்ட்ல ரெண்டு பின் எடுத்துக்கிறோம். ஒரு பின்ல switch இன்னொரு பின்ல LED கனெக்ட் பண்ண முடியுமா? That's the question. Kindly respond. Students, kindly respond. தப்பா இருந்தா கரெக்ட் பண்ணிக்கலாம். No. Okay. See, we have told a very important thing at the beginning. Features of the face on. Yes, each and every pin individually you can able to configure. Yes. Okay, fine. See, நம்ம பிரச்சனை என்ன அப்படின்னு பார்த்தோம்னா நம்ம சொல்லி கொடுத்த எக்ஸ்பெரிமெண்ட்ல சுவிட்ச் ஒரு பின்லையும் எல்இடி இன்னொரு போர்ட் பின்லையும் ஐ மீன் போர்ட் 3யோட 7th பின்ல வந்து சுவிட்சையும் போர்ட் 2வோட 0th பின்ல வந்து எல்இடியும் கனெக்ட் பண்ணும். ஸோ அதனால நமக்கு எப்படி அண்டர்ஸ்டாண்டிங் இருக்கலாம் அப்படின்னா இன்புட் டிவைஸ்லாம் ஒரு போர்ட்ல தான் கனெக்ட் பண்ணணும், அவுட்புட் டிவைஸ்லாம் இன்னொரு போர்ட்ல தான் கனெக்ட் பண்ணணும். இட்ஸ் நாட் லைக் தட். ஃபைன், இட்ஸ் நாட் லைக் தட். ஒரு போர்ட் பின்ல எல்இடி கனெக்ட் பண்ணிட்டு அதே போர்ட்ல உள்ள இன்னொரு பின் ஃபைன் kindly carefully read the question. P1.0 ல LED P1.0 ல LED will be connecting LED. Okay. P1.1 ல will be connecting switch. I hope everyone understand this. Okay, இப்போ நம்ம லேப்ல பண்ண அதே எக்ஸ்பெரிமெண்ட் இந்த கண்டிஷனுக்கு எப்படி வரும் ப்ரோக்ராம் சொல்ல முடியுமா? So what about the first line we have to type? First line என்ன டைப் பண்ணனும் ப்ரோக்ராம்ல? So first initial origin address கொடுக்கணும். Yes, very good. After that LED off பண்ணனும். P1.0 ல கனெக்ட் ஆயிருக்கு. என்ன பண்ணிக்கலாம்? ZB P1.0 அதே மாதிரி switch P1.1 ல கனெக்ட் ஆயிருக்கு. அதை இன்புட்டா கான்ஃபிகர் பண்ணலாம். என்ன பண்ணலாம்? ZB P1.1 கரெக்ட். சோ இந்த மாதிரி எழுதலாமா பாருங்க. org 0000h. ஓகே, அடுத்த லைன்ல ZB P1.0 LED கனெக்ட் ஆயிருக்கு. ஓகே, அடுத்த லைன்ல ZB P1.1 switch input configure பண்ணியாச்சு. Now what we are going to do? We are going to read. So for that part instruction we have to use move C comma P1.1 correct. Then move P1.0 comma C. Then finally we have to use the assembler command end. Is this program is going to work or not? எக்ஸாம்ல நம்ம எல்லாம் கேட்டா எழுத தெரியணும். ஏன்னா சிமுலேஷன்ல பண்ற மாதிரி வந்துச்சுன்னா ஹார்ட்வேர் பத்தி கவலைப்பட போறது இல்லை. எஸ், இந்த பர்டிகுலர் ப்ரோக்ராம்ல என்ன பண்ணிருக்கோம் பாருங்க. P1.0 ல எல்இடி கனெக்ட் பண்ணிருக்கோம் கரெக்டா. P1.1 ல ஸ்விட்ச் கனெக்ட் பண்ணிருக்கோம்னு சொன்னோம். எஸ், then we are reading move C comma P1.1 and write that logic into the port pin P1.0. That's it. Okay, fine. I hope now you people can understand. ஒரே போர்ட்டா இருந்தாலும் ஒரு பின்ல இன்புட் இன்னொரு பின்ல அவுட்புட் பண்ண முடியும். What about in the case of 8255? Is it can be done? 8255 நம்ம சொல்லி கொடுத்தோம் இல்லீங்களா? Whether we can do in that? ஞாபகம் இருக்கா? கண்ட்ரோல் வேர்ட்லாம் ஃபார்ம் பண்ணணும். போர்ட் பின் இன்புட்டா கான்ஃபிகர் பண்ணுமா அவுட்புட்டா கான்ஃபிகர் பண்ணுமா எந்த மோட்? Do you people remember? Yes, no is the correct answer. 8255 ல அந்த மாதிரி பண்ண முடியாது. பட் போர்ட் சி என்ன பண்ணிக்கலாம்னு சொல்லியிருக்கோம். இந்த கேஸ் ஆஃப் 8255 போர்ட் சி என்ன பண்ணலாம்? ரெண்டு போர்ட்டா டிவைட் பண்ணி ஒரு 4 பிட் போர்ட்டாவும் அது இன்புட்டாவோ அவுட்புட்டாவோ இன்னொன்று என்ன பண்ணலாம்? இண்டிபெண்டா யூஸ் பண்ணலாம். 2 இண்டிபெண்டன்ட் 4 பிட் போர்ட்டாவும் கான்ஃபிகர் பண்ண முடியும் 8255 ல. பட் பின் வைஸ் அப்படின்னு பார்த்தோம்னா இங்க மட்டும்தான் அது பாசிபிள். எஸ், தட்ஸ் இட். ஓகே, ஸோ கமிங் டு டைமர் பார் கவுண்டர். What about the time now? Can you people type it in the chat? What about the time now? Can you people type it in the chat? Okay, 10:34 a.m. How you people are saying now the time is 10:34 a.m. When I am asking you the time, whether you people are telling on your own without your watch or your laptop or PC or whatever it may be. Wall clock or time or watch or time சொல்ல முடியுமா நம்மளால? No, definitely no. Yes, அப்படி டைம் சொல்லணும்னா என்ன பண்ணணும்? What you people have to do? For example, நான் இங்க ட்ரிபிள் பிளாக்ல இருக்கு, இ பிளாக்ல. ஓகே, ஸோ இந்த டைம்ல வந்து டைம் வந்து 10:35 இருக்குன்னு நான் வச்சுக்கிறேன். 10:35 12 செகண்ட் இருக்குன்னு வச்சுக்கிறேன். ஃபைன், நான் மெயின் பிளாக் போயிட்டு எனக்கு டைம் இதான் இருக்குன்னு எப்படி சொல்ல முடியும்? இஸ் இட் பாசிபிள் டு டெல்? மேனுவலா பண்ணணும்னா எப்படி பண்ணுவீங்க? How you people will do without clock? Any idea? சில பேர்லாம் பண்ணியிருக்கோம். எப்படி பண்ணியிருக்கோம்? நடந்து போறப்போ ஒவ்வொரு ஸ்டெப்புக்கும் கவுண்ட் பண்ணிட்டே போவோம். 1 2 3 லைக் தட், கரெக்ட்? பட் அந்த இன்டர்வல் கரெக்டா இருந்துச்சுன்னா நம்ம என்ன பண்ணலாம்? See, I'm not relating the distance, speed and all, Surya. I am emphasizing on the counting operation. Yes, now ஒரு ஸ்டெப் எடுத்து வச்சா 1 கவுண்ட் பண்ணணும், அடுத்த ஸ்டெப் எடுத்து வச்சா கவுண்ட் 2, ஃபைன். ஸோ நான் மெயின் பிளாக் போய் ரீச் ஆகுறப்ப நான் எத்தனை கவுண்ட் பண்ணியிருக்கேன். ஸோ தட் இஸ் கோயிங் டு பி கன்சிடர்ஸ் as a second, but even if it is not going to be an exact thing, correct? There should be some reference. கரெக்டா? ஒரு சிலர் வந்து ஒவ்வொரு ஸ்டெப்பும் ஃபாஸ்டா வைப்பாங்க, ஒரு சிலர் ஒவ்வொரு ஸ்டெப்பும் ஸ்லோவா வைப்பாங்க, ஃபைன். So it's not going to be a correct thing. That means simply we have to understand one thing. Whenever we are saying timer அப்படின்னு சொன்னோம்னா, it is also going to do what operation? Digital timer அப்படின்னு சொன்னாலும் it is also going to do the counting operation. Okay, now you people consider, I am having a square wave, ஒரு square wave pulse இருக்குன்னு வச்சுக்கலாம். அதனுடைய frequency வந்து 50 Hz. Okay, so I will type it in the chat. Consider a square wave of 50 Hz. What about the frequency? 50 Hz. What is the meaning for this? What is the meaning for this? 50 Hz abhina meaning and what the value 50 refers. I hope every people will know what is meant by a frequency. Frequency na enna general. Yes. See, இது ரொம்ப பேசிக்கான விஷயம். இது தெரிஞ்சா மட்டும்தான் டைமர் புரிஞ்சிக்க முடியும். 50 Hz அப்படின்னா அதுல 50ன்றது என்ன மீன் பண்ணுது? Hertz is the unit. Okay, what is mean by 50 in there? Number of cycles. Yes, number of waves per second. Fine. Okay, sir. இப்போ நான் என்ன பண்ண போறேன் அப்படின்னு பாத்தீங்கன்னா ஒரு கவுண்டர் நான் வச்சிருக்கேன், கரெக்டா? ஸோ கவுண்டர்ல நம்ம என்ன படிச்சிருக்கோம்? On every clock pulse, the value in the counter register is going to be increment or decrement. Up counter இருந்தா increment ஆகும், down counter இருந்தா decrement ஆகும். Fine. So now we will consider up counter only. Up counter consider பண்ணிக்கலாம். Fine. நீங்க இந்த 50 Hz clock input நீங்க உங்க கவுண்டருக்கு கொடுக்குறீங்க. இனிஷியலா கவுண்ட் வேல்யூ 0 இருக்குன்னு வச்சுக்கோங்க. Fine. When the count value becomes 50, when the count value becomes 50 Hz சிக்னலை நான் இன்புட்டா கொடுத்தா எவ்வளவு நேரம் ஆகும் எனக்கு அங்க 15ன்ற கவுண்ட் ரீச் ஆகுது? எஸ், 50 சைக்கிள்ஸ். 50 சைக்கிள் நடந்தா எவ்வளவு டைம் ஆயிருக்கும்? 50 சைக்கிள்ஸ் நான் கவுண்ட் பண்ணியிருக்கேன் அப்படின்னா எவ்வளவு டைம் ஆயிடுச்சு? என்ன சொன்னீங்க? 50 cycles per second. அப்ப 50 cycles எனக்கு கவுண்ட் பண்ணிருக்கேன். What about the timing now? 1 second. That's all very good. If my count value is 300, what about the timing? Yes, 6 seconds. That's it. See, we are having a reference clock, correct? A reference waveform that we generally call it as clock input. இப்போ நமக்கு புரிஞ்சிருக்கும் ஏன் மைக்ரோ ப்ராசஸர் மைக்ரோ கண்ட்ரோலருக்கு clock input கொடுக்கிறோம். It is going to work with reference to that signal only. இந்த பல்ஸ் முடிஞ்சதுக்கு அப்புறம் தான் அடுத்த ஆபரேஷன். இந்த பல்ஸ் முடிஞ்சதுக்கு அப்புறம் தான் அடுத்த ஆபரேஷன். Based on that only we are telling the speed of execution of a computer. Correct? Okay. Now coming to this topic, 8051 la timer bar counter. What it means? It can be used as timer, also it can be used as counter. Both can be done. We are having a hardware which is going to function as both timer as well as counter, but only one at a time. Fine. Timer kum counter kum there is a very a leaf difference. That's all. A very thin difference. There is a thin wall between the timer and counter. Operation wise both are same. ரெண்டுமே ஒரே மாதிரி தான் ஒர்க் ஆகும். பட் தேர் இஸ் கோயிங் டு பி எஸ் Small difference. Then fine. First we will get. So 8051 microcontroller has two independent. That's very, very important. Okay, two timer bar counter independent. What it mean? What is mean by independent? See, if I am assigning task to two students, okay, when it is going to be independent? Yes, separate. Where task is independent. That means you can use one of the timer. Okay, you can use one of the timer for a purpose. Another timer you can use it for some other purpose. Yes, both are going to be independent to each other. See, இதுல வந்து count increment ஆகுது. அதே டைம்ல தான் இங்க நமக்கு count increment ஆகுது. So இது இவ்வளவு count தான் பண்ணணும், இது இவ்வளவு count தான் பண்ணணும் restriction கிடையாது. All the timers are going to be, all the two timers, I mean both the timers are going to be independent in nature. So இத நான் ஒரு certain delayக்காக generate பண்ணலாம். இன்னொரு டைமரை வேற டைமிங் ஜெனரேஷனுக்காக யூஸ் பண்ணிக்கலாம். Both are going to be independent. Fine. ரெண்டுமே கவுண்ட் ஜீரோல இருந்து ஸ்டார்ட் ஆகும்னா கிடையாது. இதுல கவுண்ட் ஜீரோல இருந்து ஸ்டார்ட் ஆகலாம், அதுல வேற வேல்யூல இருந்து ஸ்டார்ட் ஆகலாம், வாட் எவர் இட் மே பி. ஃபைன். What about the size of the counter? What about the size of the counter? Timer bar counter? Yes, it is 16 bit. So what is the maximum value you can put into the timer bar counter? Maximum என்ன வேல்யூ நான் லோட் பண்ணலாம்? 16 bit அப்படின்னு சொன்னா you can type it. Yes, very good. In hexadecimal it is FFF. What about the minimum count value we can put? Minimum count value. Yes, very good. Okay. So timer bar counter 0, timer bar counter 1. That is the name of the timer bar counter available in 8051. சரிங்களா? See, எந்த ஒரு மைக்ரோ கண்ட்ரோலர் போனாலும் இந்த மாதிரி ஒரு நேமிங் கொடுத்துருப்பாங்க. Say for example, PIC மைக்ரோ கண்ட்ரோலர் இருக்கு. Okay, PIC மைக்ரோ கண்ட்ரோலர். அந்த மைக்ரோ கண்ட்ரோலர்ல போர்ட்டோட நேம்ஸ் வந்து போர்ட் A, போர்ட் B, போர்ட் C அப்படிதான் நேம் பண்ணிருப்பாங்க. ஃபைன். வெயிட் a minute. Okay, fine. So we are having two timer bar counter. The naming is very important. We are having timer 0 and timer 1. Okay. See, நிறைய இடத்துல timer bar counter னு போடுறோம். அதோட மீனிங் என்னன்னா it can be used as timer both as well as counter. Fine. But only one at a time. ரெண்டு ஆபரேஷன் ஒரே நேரத்துல பண்ண முடியாது. So both are binary up counter and they have a 16-bit register to hold the count value formed by cascading 2 8-bit SFR. That's very, very important. Sir, நம்ம 8051ல படிச்ச எல்லா ரெஜிஸ்டருமே ஆல்மோஸ்ட் 8-bit தான். கரெக்டா? ஸ்பெஷல் ஃபங்க்ஷன் ரெஜிஸ்டர், எஸ்பெஷலி ஸ்பெஷல் ஃபங்க்ஷன் ரெஜிஸ்டர். What about DPTR? What about DPTR? What about the size of DPTR? Yes, very good question by Anthony Surya. Sir, can we configure timer bar counter 0 as timer and timer bar counter 1 as counter? Yes, you can do it. That's what we are speaking. Independent. ஒன்னத்த டைமர் ஆகும் இன்னொருத்த கவுண்டர் ஆகும் கான்ஃபிகர் பண்ண முடியும். Yes, it is possible. Yes. Okay, 16 bit. But physically நமக்கு 16 bit register இருக்கா SFR ல? What are the two register combinedly we call it as DPTR? Yes, DL DH இல்ல DPL DPH அப்பா? DPL DPH, correct? Yes, very good. Similarly, இங்க நம்ம என்ன சொல்ல போறோம் அப்படின்னு பாத்தீங்கன்னா each timer bar counter it is going to have a 16-bit count value to be held using two 8-bit register. என்னன்னு பார்க்கலாமா? The very first point, binary up counter அப்படின்னா மீனிங் என்ன? hexadecimal number 9 க்கு அப்புறம் என்ன வரும்? A. இதே வந்து நான் வந்து பைனரி கவுண்டருக்கு பதிலா நான் வந்து BCD கவுண்டர்னு சொன்னா மீனிங் என்ன? When I say BCD counter after 9 it is going to be 10 only. Yes, very good. Okay, then one more thing, up counter அப்படின்னா மீனிங் என்ன? For every clock input, for every clock pulse it is going to increment by 1. That we call it as up counter. Down counter na meaning enna? If I say down counter, what is the meaning for that? Decrement ஆகும். That's it. Yes? Okay. Okay. நல்லா கவனிங்க. ரெண்டு SFR register TH0, TL0. ரெண்டுத்தையும் சேர்த்தா timer bar counter 0 ஓட 16 bit register ஆயிடும். That's it. DPTR மாதிரி இங்க யூஸ் பண்ண முடியாது. Individually you have to write the upper byte, lower byte so that it is going to have a 16 bit count value. Fine. DPTR அப்படின்னு சொன்னா மீனிங் என்ன? DPH, DPL combine பண்ணி 16 bit data நீங்க டைரக்டா எழுத முடியும். Whereas in the case of the timer bar counter register, individually you have to write the lower byte and the higher byte. Fine. So 4 register நமக்கு இங்க படிக்க போறோம். These registers are used to hold the count value. That's all. Timer இருந்தாலும் சரி, counter இருந்தாலும் சரி, count value அப்படின்னா சொல்லுவோம். Fine. Because both is going to do the count operation only. Fine. Okay. TH0/TH1 is higher byte register. TL0 and TL1 is lower byte register. You can see this. This will provide you a clarity. Timer bar counter 0 register அப்படின்னு பார்த்தா TH0 higher byte, TL0 lower byte. Combined are ரெண்டு சேர்த்து 16 bit. Fine. But programming நீங்க என்ன பண்ணணும்? Lower byte, higher byte அப்படிதான் எழுத முடியும். You don't have any provision to write a 16 bit count directly. Lower byte, higher byte ரெண்டுமே நம்ம ஸ்பெசிஃபை பண்ணி தான் ஆகும். Fine. Then one more important thing, one more very important thing, when your timer is running, at that time you should not load the count value. That's very very important. என்னோட டைமர் ரன் ஆயிட்டு இருக்க டைம்ல நான் என்ன பண்ண முடியாது, கவுண்ட் வேல்யூ லோட் பண்ண முடியாது. It may lead to an error. நம்ம ஜெனரேட் பண்றக்கூடிய டைமை தாண்டி போகலாம் இல்ல கம்மியாகலாம். Fine. Are you clear about this? நான் சொல்றது புரியுதுங்களா? என்னோட டைமர் ரன் ஆயிட்டு இருக்கப்ப நான் கொண்டு போய் ஒரு கவுண்ட் வேல்யூ அதில் போடக்கூடாது. That's very very important. So இப்போ கவுண்ட் வேல்யூ நான் போடணும்னா என்ன பண்ணணும்? What I have to do? என்னோட டைமர் பார் கவுண்டரை நான் ஸ்டாப் பண்ணிட்டு தான் என்ன பண்ணணும்? கவுண்ட் வேல்யூ I can do. Fine. So as of now நமக்கு எத்தனை டைமர் பார் கவுண்டர் இருக்கு? 2. What about the name? Timer 0, timer 1. Okay. What are the registers we are having to load the count value? Timer 0 க்கு TH0, TL0. Combinedly 16 bit count value you can put. Fine. Then for timer 1, TH1, TL1. Combinedly we can put the 16 bit value for timer 1. Fine. Now you consider this working as a timer. The timer bar counter வந்து டைமரா எப்படி ஒர்க் ஆகும் அப்படின்னு பாத்தீங்கன்னா counts the internal clock pulse. That's all. Counts the internal clock pulse. ஒரு fixed frequency input நான் இந்த சர்க்யூட்டுக்கு இன்புட்டா கொடுத்தனா, கிளாக் இன்புட்டா கொடுத்தனா, it is going to function as a timer. சொல்றது புரியுதுங்களா? நான் ஒரு எக்ஸாம்பிள் சொன்னேன். 50 Hz சிக்னலை நான் ஒரு கவுண்ட்டுக்கு இன்புட்டா கொடுத்தனா, for every 50 count it is going to be considered as 1 second. 1000 count எனக்கு பண்ணிருந்துச்சுன்னா எத்தனை செகண்ட் சொல்ல முடியுமா? frequency நான் 50 Hz கொடுத்து எனக்கு 1000 count பண்ணிருக்கு அப்படின்னா what about the timing? For every 1 second it is going to count 50 times. So how much 50 I am having in 1000? 1000 divided by 50 போட்டோம்னா 20 second. Okay, 20 second is the very good correct answer. That's a very correct answer. Okay, fine. இங்க நம்ம டைமருக்கு எப்படி இன்புட் போகுதுன்னு பார்க்கலாம். Fine. The operation of timer 0 and timer 1 it is going to be similar only. So we are generally marking it as timer X. இங்க 0 போட்டா மீனிங் என்ன? timer 0, 1 போட்டா timer 1. ரெண்டுத்தோட ஆபரேஷனும் சிமிலரா தான் இருக்க போகுது, கன்ஸ்ட்ரக்ஷனும் சிமிலரா தான் இருக்கு. Fine. Okay, now we are having a 16 bit register. This is going to be considered as a timer. Okay, now carefully note down how the timer operation happening in 8051 அப்படின்னு பார்த்தோம்னா oscillator frequency. What about the typical value of the oscillator frequency? Can you people type it in the chat? நம்ம கனெக்ட் பண்ணக்கூடிய கிறிஸ்டல் அதோட frequency இங்க எவ்வளவு இருக்கலாம் அப்படின்னு பாத்தீங்கன்னா டிபிக்கலா 12 megahertz. About the frequency 12 megahertz. Okay, fine. நல்லா கவனிக்கணும். Please carefully understand. உங்களோட CPU எவ்வளோ கிளாக் இன்புட் நம்ம கொடுக்குறோமோ அதே கிளாக் இன்புட்டை நான் டைமர் பார் கவுண்டருக்கு கொடுத்தோம்னா your CPU cannot able to control your timer bar counter. Why? என்ன ரீசன் சொல்ல முடியுமா? Your peripheral must be always slow down. உங்களோட பெரிஃபரல் இருக்கு இல்லையா, அதனுடைய ஆப்ரேஷன்ஸ் சிபியூட ஆப்ரேஷன்ஸோட கம்மியான ஸ்பீட்ல தான் ரன் ஆகும். Then only your CPU can monitor the operation going in your peripheral. Is it clear to everyone? மின்னல் வேகத்துல என்னோட டிவைஸ் ஒர்க் ஆகுதுன்னா அதுக்கு ஈடு கொடுக்குற மாதிரி ப்ராசர் அதை விட ஃபாஸ்டா ஒர்க் ஆகும். எஸ், இஸ் இட் கிளியர் டு எவ்ரிவன்? எஸ், ஃபைன். சரி, நான் உங்களுக்கு ஒரு 10 ஒர்க்கு கொடுக்குறேன் அப்படின்னா இந்த 10 ஒர்க்கை நீங்க முடிச்சு எனக்கு சப்மிட் பண்றீங்க பாருங்க, அந்த டைமிங் ஜாஸ்தியா இருந்தா தான் என்னால மானிட்டர் பண்ண முடியும். நான் ஒர்க்கை கொடுத்துட்டு அடுத்து நான் ஒர்க்கு கரெக்ட் பண்ணிட்டு இருக்கப்பவே நீங்க எல்லா ஒர்க்கையும் கரெக்ட் பண்ணி கொடுத்துட்டீங்கன்னா ஐ ஹாவ் டு வெயிட். ஃபைன். So generally, the CPU is running at a higher speed when compared to the peripherals. Fine. So அப்ப இங்க என்ன பண்றோம்? இனிஷியலா clock-ஐ divide பண்றோம். Okay. Yes. Here the oscillator input, whatever the frequency we are giving, it is divided by 12. அப்பனா என்னோட டைமருக்கு என்ன frequency input போகும் சொல்ல முடியுமா? 12 MHz input நான் கொடுத்தேன்னா என்னோட டைமருக்கு எவ்வளவு frequency போகும்? 1 MHz. Fine. We have not yet covered one topic. Mission cycle of 8051 cover பண்ணல. Here in 8051, 12 clock pulses constitute one mission cycle. Kindly note down. எத்தனை clock pulse ஆகும் ஒரு mission cycle-க்கு? All the mission cycle of 8051 is having the time duration of 12 clock pulses. Kindly note down. So how many clock pulses constitute one mission cycle in 8051? Can you people say? Yes, 12 clock pulses makes one mission cycle. Okay, so for that reason only here the clock is divided by 12. That means what? Indirect இங்க நம்ம என்ன சொல்றோம்? For every one mission cycle, what about the count value in timer? What it is going to be? Incremented by 1. Very good. The count value of the timer gets incremented by 1 for every one mission cycle. That means the oscillator frequency is divided by 12 and it is given to the timer bar counter. Fine. So 1 MHz. If it is 12 MHz, 1 MHz on the frequency la is going to operate. That means, can you people say for a single increment in the count value, how much duration it is going to take? ஒரு மிஷின் சைக்கிளுக்கு ஒரு தடவை இன்க்ரிமெண்ட் ஆகுதுன்னு சொல்றோம். வாட் அபவுட் த டைம் பீரியட்? ஃப்ரீக்வன்சி FOC by 12 சொல்றோம். வாட் அபவுட் த டைம் பீரியட்? T equal to 1 by f. Correct? Here the operating frequency is FOC by 12. What about the timing now? 12 by FOSC. 12 divided by FOSC. Can you say like that? T equal to 12 by FOSC. Fine. Substitute பண்ணி சொல்லுங்க. 12 MHz crystal நான் யூஸ் பண்ணனா, what about the timing for each count? ஒரு கவுண்ட்க்கு எவ்வளவு டைமிங் ஆகும்னு கேக்குறேன். So T equal to what we can put? 12 divided by 12 MHz. Yes. So here the time period for a single increment can be given in this way. So T equal to 12 by FOSC. நம்ம ஆல்ரெடி என்ன சொன்னோம்? 12 MHz ன்னு சொன்னோம். So 12 divided by 12 MHz. 12 by 12 which is equal to 1. Correct? 1 by mega equal to micro. 1 micro. What it means? The minimum timing which can be generated by your 8051. என்ன அப்படின்னு பார்த்தோம்னா 1 microsecond. Fine. So ஒரு clock input க்கு, the clock input is divided into 12. So for every one mission cycle, the timer is getting incremented by 1. In other words, we can say if I connect 12 MHz crystal, for every 1 microsecond, it is going to increment by 1. That's it. Fine. Now it's very very important. Okay, initially நம்ம வந்து டைம் வந்து 0 ன்னு வெச்சுக்கலாம். Fine. Initially time வந்து 0 ன்னு வெச்சுக்கலாம். Count value 0 இருக்குன்னு வெச்சுக்கலாம். Fine. So after 50 microsecond, what must be the count value I will be getting? நான் எக்ஸாம்பிள் பேசுறது எல்லாமே 12 மெகாஹெர்ட்ஸ் கிறிஸ்டல் வச்சு பேசுறேன். Yes, can you say? So எனக்கு 50 கவுண்ட் வந்திருக்கு அப்படின்னா, ஐ மீன் 50 மைக்ரோசெகண்ட் அப்படின்னு சொன்னா எத்தனை கவுண்ட் வேல்யூ எனக்கு வந்திருக்கணும்? If I want to generate 50 microsecond, initially count value 0 பண்ணியாச்சு. Fine. I have to generate a 50 microsecond timing. So what must be the count value till I have to wait? என்ன வேல்யூ வந்தா 50 மைக்ரோசெகண்ட் ஜெனரேட் ஆயிருக்கு? எஸ், கவுண்ட் வேல்யூ 50 இருந்துச்சுன்னா டெசிமல்ல 50, கரெக்ட்? இன் ஹெக்ஸாடெசிமல் இட் இஸ் 32H. ஓகே, இன் டெசிமல் இட் இஸ் 50, கரெக்ட்? ஸோ எனக்கு 50 கவுண்ட் வந்துச்சுன்னா எனக்கு நான் ஜெனரேட் பண்ணக்கூடிய டைம் முடிஞ்சு போச்சுன்னு அர்த்தம். ஃபைன். ஓகே, I want to ask you one thing. Why we are going for such hardware அப்படின்னு பார்த்தோம்னா, I will give the count value to the timer bar counter. Okay, after the time I want to generate, my timer bar counter should generate an interrupt. நீ ஜெனரேட் பண்ண சொன்ன டைமை நான் ஜெனரேட் பண்ணி முடிச்சிட்டேன். The time is over. There should be an interrupt from the timer bar counter to your CPU. 8051 உள்ள CPU க்கு interrupt போகணும். யார்கிட்ட இருந்து? timer bar counter இருந்து. What it is going to indicate? I'm going to load some count value. அந்த count value பொறுத்து இந்த டைம் ஜெனரேட் ஆகும் நான் கால்குலேட் பண்ணி தான் எழுதிருக்கேன். Fine. Once the timing is generated, this hardware timer should generate an interrupt that we call it as timer interrupt அப்படின்னு சொல்லுவோம். But it happened only when the timer gets loaded. Let's see. So with this we will stop today's session. Okay, timer overflow அப்படின்னா when the 16-bit count value gets roll over from maximum value to minimum value. What is the maximum value you said? F. அதுக்கப்புறம் ஒரு மிஷின் சைக்கிள் வந்தா கவுண்ட் ஒன்று இன்க்ரிமெண்ட் ஆகும். இன்க்ரிமெண்ட் ஆனா கவுண்ட் என்ன ஆயிடும்? It becomes 000H. Correct? Initial count value on that. Correct? This process changing from maximum value to minimum value, in the process க்கு பேர் என்ன சொல்றாங்கன்னா timer overflow. Overflow means what? Exceeds beyond the limit, that we call it as overflow. Correct? So 16-bit count value தாண்டி எனக்கு count value போனுச்சுன்னா that we call it as overflow. So it produces an interrupt called timer overflow. Fine. So out of the 5 interrupts, 3 interrupts are internally generated interrupts. அதுல ஒன்னு timer 0 overflow interrupt, இன்னொன்னு timer 1 overflow interrupt. ரெண்டு interrupt வந்து timerனாலே generate ஆயிடும். Fine. Okay. So please kindly note down what we set it as timer overflow. Whenever the maximum count value, whenever the count value exceeds beyond the maximum value, that we call it as timer overflow. When it happens? When the count value is maximum, FF, when I am incrementing the count value by 1, that time timer will get overflow. Fine. அப்பதா interrupt generate ஆகும். Fine. Okay. Can you people tell me one answer? If I put the count value as 50 in the timer bar counter register, after 50 cycles, whether it is going to interrupt the microcontroller? கொஞ்சம் imagine பண்ணி சொல்லுங்க. இதோட ஸ்டாப் பண்ணிக்கலாம் செஷன். Time is almost 11. We will stop the session with this. Okay. என்னோட question clear புரிஞ்சுதா? If I put the count value as 50 in that timer bar counter register, whether it is going to generate the 50 microsecond? Definitely no. Yes, ஒவ்வொரு மிஷின் சைக்கிளுக்கும் கவுண்ட் இன்க்ரிமெண்ட் ஆகும். எப்படி இன்க்ரிமெண்ட் ஆகும்? 51, 52, 100 போயிடும். 100 போனா எனக்கு ஓவர்ஃப்ளோ நடக்குமா? கவுண்ட் வேல்யூ 100 போனா எனக்கு ஓவர்ஃப்ளோ நடக்குமா? இன்டரப்ட் ஜெனரேட் ஆகுமா? டெஃபினெட்லி நோ. இங்க கவுண்ட் வேல்யூ எப்படி லோட் பண்ணுன்றது லேட்டர் கிளாஸ்ல நான் சொல்லி தரேன். ஃபைன். வாட் மஸ்ட் பி த கவுண்ட் வேல்யூ யூ ஹாவ் டு புட் இன் த கவுண்டர் ரெஜிஸ்டர் so that after 50 count the overflow scenario has to happen. That we will teach you later. Okay. as of now timer அப்படின்னா மீனிங் என்ன? Fixed frequency. We are going to give it as a clock input. So for every one cycle, the count value is going to increment. Okay. Known frequency count panna, அது பேர் என்ன? Timer. Fine. The next class we will discuss about the counter and its operation. Fine. So with this we will stop today's session. So in the slide la irundhu continue பண்ணிக்கலாம். சொல்லு. Yes, Sajid sir. Okay. 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 See, லிஸ்ட் கொடுத்துடலாம் நம்ம. ஓகே, லிஸ்ட் கொடுத்துடலாம். நிறைய டைம் கொடுத்தாச்சு. அப்சர்வேஷன் அண்ட் ரெக்கார்டுக்கு ஆன்லைன்ல அப்லோட் பண்றதுக்கு நிறைய டைம் கொடுத்தாச்சு பசங்க எல்லாருக்குமே, கரெக்டா? பட் இது வரைக்கும் நீங்க லோட் பண்ணல அப்படின்னா மீனிங் என்ன? யூ பீப்புள்ஸ் ஆர் நாட் டேக்கனிங் கேர். என்ன பண்ணிடுவாங்க அப்படின்றதுதான். ஃபைன். ரெக்கார்ட் டைமுக்கு சப்மிட் பண்ணல அப்படின்னா உங்களோட இன்டர்னல் மார்க் கண்டிப்பா புவரா தான் இருக்கும். ஃபைன். ஈவன் இன்டர்னல்ல ஃபெயில் ஆனா கூட ஆச்சரியப்படுறது கிடையாது. ஸோ கைண்ட்லி டேக் கேர்.